Ladies and gentlemen, please welcome our next speaker, Kimpel, presenting the topic, Tracing Kafka with OpenTelemetry.
On this side of the screen, please do use Slido to ask questions if you have any during the presentation. After the presentation, 45 minutes. Take some 5 minutes, as much as you can, for questions. You can ask questions live afterwards, or again, write them down. You can also find the speaker outside of the presentation hall afterwards and talk him and hit him up with questions or just chit chat. So go ahead. Thank you.
Hello, everyone. Hello, Vilnius. I will talk about, as it was introduced, on tracing Kafka with OpenTelemetry. I mentioned why this is important and what benefits it'll bring you when you apply this in your day-to-day job. Safe harbor slide, I won't go into that. My name is Kimpel. I work for a company called Relic, which is an observability tool. It's just a hype topic nowadays. Previously, monitoring, observing your systems. I'm a developer relations engineer at Relic, have been in the pre-sale capacity before that. I'm living in south of Germany and excited to be here today. So I represent Relic and I work for Relic, but all of the concepts that I'm sharing today are not related to Relic at all. I will be using Relic as a backend for the telemetry that I'm collecting, but basically you can apply the same concept in all of your environments, independent of whether you're using Relic or not, or you're using some open source components. So I hope this is interesting, and like I said, it will apply to all the concepts, not specifically to Relic. So I think I have the feeling I don't need to talk about Kafka too much. It is an open source distributed event streaming solution. It has a lot of benefits. It is an open source environment, right? High performance, scalable, persistent storage. So really interesting topic. There are some vendors out there that actually use and provide this as a managed service as well, like things like Confluent. So this is around Kafka, and the challenge is typically if you're running an application, you have some kind of producer, some consumer on the other side that actually exchange messages over Kafka. In general, if you don't apply some concepts that I'm sharing here today, you will basically see a broken connection, right? You will see the producer producing messages, the consumer consuming. But if you want to trace all of the requests through Kafka and some additional benefit that it brings, it'll basically look as a black box. So it's really important to apply some tracing in these applications so you can get a full end-to-end perspective of your entire application that is maybe composed of multiple microservices. So that brings me to OpenTelemetry. Who in the audience has heard about OpenTelemetry yet? Okay. So I would say good half of the people. It is a really interesting topic. Like I said, I'm coming from a company called Relic. We used to be in the APM, application performance monitoring space, for many, many years. We had our own, agents that you can attach to your applications. But really, the benefits of OpenTelemetry is, this is an open source project. It is part of the CNCF. It's an incubating project within the CNCF community. It was actually formed through two different projects that existed prior to OpenTelemetry. One is OpenTracing, that was focusing on the tracing aspect, and then OpenCensus, which is focused on the metrics. So typically, the typical telemetry that you will see is kind of like traces, metrics, and logs that you want to collect. And OpenTelemetry covers all of these telemetry data types in a single solution. It's vendor agnostic. It has some set of APIs, SDKs that you can use and apply. It basically standardizes the way you collect and observe your applications in a really efficient manner. And then you can use that telemetry that you collect from your applications, your infrastructure, to send it to another open source environment, things like Jaeger, or some other environments, or like a full observability platform, for example, like New Relic. So really, why this was introduced, the industry wanted a standardized way on having a vendor-neutral way of collecting the data, interoperable, kind of like, connecting many pieces together in a standardized way and form, and highly configurable. I will go into the details of why this is important and where you can apply these customizations, but this is really the benefit. And the statistics down there mention that Gartner predicts that by 2025, which isn't too far out from today, they expect that 70% of all cloud native environments will be using OpenTelemetry in some way or form. So, like I mentioned, there's a lot of benefits, for various people, for various personas that you typically deal with. For management, it's a standardized way you implement once, and don't need to think about like any vendor lock-in or anything. There's some really interesting benefits there. For me, I think the most important thing is really the vendor-neutral aspect. OpenTelemetry is here to stay for a long time, and if you using some kind of observability, some monitoring for your applications today, it may be interesting to think about switching to OpenTelemetry. But if you haven't started like monitoring your applications for performance and exceptions that occur, I highly encourage you to look into OpenTelemetry, because this is really the future of observing your applications and infrastructure. The concept of collecting your data from your applications and services is kind of like that you will use some kind of pipeline that you can configure. And what you see here on the screen is really just a typical snapshot of a OpenTelemetry implementation. You can see on the left-hand side, you can use some applications, some languages. If your applications are written in Java, .NET, whatever languages you use, there are some ways on how to so-called instrument your applications, like observing your metrics, traces, and logs from your applications. You can then send this into this pipeline, and I'll explain what the benefits of these pipelines are. Another aspect of sending data into that pipeline can come from your cloud environments, from your infrastructure, from other services like the hyperscalers like AWS, Azure. Microsoft is also heavily invested in OpenTelemetry. So if you're using some kind of services, it could be even serverless functions that you use. Typically, OpenTelemetry is already baked in, and you can also use that to add additional information to your environment. So, like I said, the first thing is to collect the data, and this is where the so-called receiver comes into play. It will receive your data, your telemetry. This whole pipeline that you see here that can run locally in your own environment, like if you have some Kubernetes environment, some local infrastructure, that whole pipeline can run in your own premises. This does not need to run in some kind of cloud environment. The middle piece, the processing part, is interesting because it helps you to, for example, batch your traces, your metrics and logs, so that you don't send the data immediately to a backend. You can batch it, you can process it, you can decorate the information with additional information, you can obfuscate data if you identify any things that you don't want to capture in some kind of observability backend. You can also obfuscate that data or also remove data. If someone, for example, decided to send in some debug logs, you can identify those and remove them already in this pipeline of the OpenTelemetry environment. And then, lastly, the exporter is then a component that helps you to send the data to some backend that you're using in order to analyze the data. The traces that you typically capture are nice. You can look at them in maybe a console output, but really in order to help you analyze the data, what is going on, see all of the traces in context, and maybe identify any anomalies that are happening, you want to export the data, and you can use various kinds of exporting backends. Like I said, you can use Jaeger, for example, for traces. You can use some log management system to send the logs, and the important thing is also that it doesn't need to be like one environment that you send the data to. You can send the logs over here, you can send the traces somewhere else. So you have full control over what is happening in this pipeline. And that is really, in my opinion, the biggest benefit of having such a pipeline, because it helps you to define and process all of the data that you collect. And of course, we as Relic, we also have like an endpoint, and so-called OTLP endpoint, OpenTelemetry line protocol, that receives native OpenTelemetry data and then, stores it and, does some interesting aspects on how to visualize and help you analyze the data. All right. But, let's just all go into OpenTelemetry, right? Or is there anything, some design considerations or some things that you may want to look at? And this is what I'll quickly talk to in the next couple sections. So you can imagine, OpenTelemetry also supports basically two different ways on how you can instrument your applications. On the left-hand side, you see kind of like your ingredients, like if you want to bake a cake, you can use the different powders and stuff like that, right? You have full control over what is happening and what you want to observe within your applications, which is nice because I can decide, maybe which pieces in my application need some, deeper instrumentation. Maybe I need to get some details into, some more important aspects of my application. For example, if you think about like a retail environment, the cart and the checkout is probably one of the biggest and most important aspects. But you can decide what it is you want to instrument and observe. On the other hand, OpenTelemetry also allows you to have some kind of, like an auto instrumentation, which is called, and you can use that to, basically just attach some form of agent to your applications, and then it'll automatically instrument your application and try to identify things that are of interest, but in an automated fashion. The pros and cons are, on the left-hand side, you have full control, but you also have to, add something into your code. So you will bake in some dependencies. You will, change your code to maybe reflect some, custom spans that you create, some custom data. On the other side, you can just attach an agent, but it only gives you that much level of detail, right? So it's kind of like a balance, and you can pick and choose as well. But these are the, typically the design considerations. And what I'll show you in the next couple minutes is kind of like, how this actually looks like and how this, could appear in your applications. What I always encourage you to look at as well is if you go to opentelemetry.io, there's like a status and releases page in the documentation. This highlights the maturity of the different environments. Like if you're using Java, .NET, these are, probably the most mature environments. Depending upon what it is you're using, based on the telemetry, like traces, metrics, and logs, you will have, full support already, and you can use it, also recommended in production already. But in some other languages, I'm thinking like Rust, for example, this is basically in beta, alpha stage, whatever. But I'll highly encourage you to look at that page on a regular basis because this changes frequently. This is a snapshot I took last year in the summer. I just went in today to gather like an updated snapshot, and you can see a lot more support, a lot more is happening, a lot of things that are in stable configuration are now. PHP went into stable for all the different telemetry types, which is kind of interesting. So always highly encourage you to look at that before you start implementing. All right, design considerations, I won't go into the details of that specific slide. You can read through, but basically, do you already use traces in your applications? If not, I see a lot of customers and environments that are heavily relying on logs, maybe historical reason, things that to consider when starting with OpenTelemetry, what is it that you want to observe? What type of telemetry do you want to collect? And these kind of things are highly, of interest when you start your journey in OpenTelemetry. But it is, like I said earlier, it is here to stay and worth looking into. All right, so let's get into the details how this could look like in your application. What I am showing in the next couple of minutes is kind of like a sample application. In that specific scenario, I'm using a Java Spring Boot environment. The concepts really apply in all the different languages in a similar fashion. The syntax may be a little bit different, but basically the concept is really the same in all the different programming languages. So what I'll first go through is kind of like, remember that cake. I'll start with the auto instrumentation. So basically just using an agent, which you can see here. This is a run script that will, start up my application. And what I'm doing here is kind of like exposing some environment variables. In this case, the -java agent, adds to your JVM options. And what you see here in the back of it is kind of like a jar file that I'm just attaching to the JVM at startup time. This is basically it, what I need to do in order to get my application up and running using OpenTelemetry. I don't need to change my source code. I don't need to change anything in my application itself. I'll add this Java agent, and then of course, I need to send the data somewhere. Remember that pipeline that I showed earlier. In this case, I'm using this OTLP, OpenTelemetry Line Protocol endpoint. Like I said, this applies in all the different observability concepts. In this case, I'm using our Relic endpoint for OTLP, for OpenTelemetry telemetry. And then, since this is an endpoint, I need to attach some kind of header information and API key in order to send the data and, for the backend to accept that request coming in. This is basically it. I can start up my application. I can start up my sample, like a producer, a consumer, and some other services. And without anything that I need to configure in the application, I will get then insights into how that application looks. This is kind of like a screenshot from our environment, but basically this is the high-level architecture that I got generated automatically. You can see on the left-hand side the producer, the consumer. I have added some additional things, to the consumer just to show some additional more interesting information. But basically Kafka sits in between, right? So the producer sends in some data into Kafka, the consumer, subscribes to it and reads the data from that Kafka topic. If I then look into like the tracing, and again, this could be some open source component like Jaeger. In this case, this is the standard view for distributed tracing in the Relic. I will then see the breakdown, kind of like that waterfall view of what does a single request look like. This is what we're looking at, is a single request. You can see the trace ID at the top as well. But basically, I can see the producer sending in some data into Kafka. I see a huge block of empty space. This is kind of like the lag. This could be the lag of the consumer reading from the Kafka topic. And at some point, the consumer kicks in and reads the data, and then my trace follows through. This is great insights already, right? I mean, I didn't have to change my application, but I can see a full trace all the way from the beginning, like the producer, to even like some backend service that I added as well. But I see also, not Kafka as a black box, but I can see at least, hey, there's something happening. Kafka sits in between and basically processes that data, and so I can, easily see, how that breaks down. I can see some huge chunks of code that are, being executed, and where the time is actually spent in the whole journey of that specific request. Can anyone spot like a challenge with that approach? Like, I'm using auto instrumentation, so I didn't change my code. Does anyone, notice anything on that screen that may be of interest? Exactly. That's exactly it. You see at the bottom, there's some, a span, a trace is typically, composed of multiple different spans, like, parts of a whole trace. And what's happening is that, there's some uninstrumented time. With the auto instrumentation, the visibility into my code ends at some point. This is the caveat. I mean, it's easy to configure auto instrumentation, but at the same time, on the other hand, it's like it only goes so deep into my code, which is on purpose, right? And this is exactly what I am referring to. I can see, this part of the span, takes 3 seconds, but what is happening in that 3 seconds, I have no idea. And this then brings me to, the other option of, manually instrumenting my code with OpenTelemetry. In this case, what I need to do is, in this case, I'm configuring some properties of my application. Again, the OTLP endpoint, where do I want to send that telemetry data to from the OpenTelemetry pipeline. I have some license key again for our API key. And maybe important, I can also, of course, configure much more details of that environment. I can specify, do I want to capture the Kafka telemetry, right? Do I want to add any additional information from my Tomcat, in this case, as my web server? So I have full control over what is happening, and I can highly configure this environment. The details can be found in the docs of OpenTelemetry, but this is just an example. So if I then look into the actual code, like I said, in the case of the auto instrumentation, I don't need to do anything. It's just adding the agent and it works. In contrast, in this example, I do need to add some code and some configuration for my OpenTelemetry configuration. In this case, I'm highlighting one section here. This is the tracing aspect. And it basically configures a tracer provider that I can then use within my code in various different parts of the application. So this is kind of like a one-time thing, typically in a static mode within my application. But this is what I need to do once for each of the applications that I need to configure. You can see, I'm also, basically, I'm sending, or adding in the OTLP endpoint here, the API header, and so on. But this is now as part of my code that I'm executing. When it comes to the Kafka instrumentation, there's also something that I need to configure. Basically, for the producer side, I need to add in a tracing interceptor. This is a standard way for Kafka to intercept something in the case of some producer adding some messages into Kafka topic. And the same is then happening also for the consumer side. So on the consumer side, I also have to add some kind of interception that actually then listens to some information within a message in the topic. What actually happens behind the scenes is, what OpenTelemetry does, it actually adds some header information to each of the messages, so that the producer will add some tracing context to that message, and on the consumer side, it'll read that context and basically process it from there. So basically, what we've seen with the auto instrumentation also works in here, but I have to do some and add some additional things to my code. For the manual instrumentation, a trace looks pretty much the same. You will notice that maybe the span names and the information there is a little bit different, because I can customize this to my specific needs. Maybe I have my own naming conventions across my entire organization. I can highly customize this and name it in a meaningful way. And also the uninstrumented time that we have seen earlier, now I know where this is coming from. This is a long-running task. I could go into more detail in this and break it down even further, but just as an example, I basically just created a custom span for this specific method that I'm calling. Basically, what happens is I just, in order to do something, I added a sleep in here just to add some, span duration for this specific task. But importantly, what you can see here, the tracer provider that we used earlier, I'm creating a custom span here. I name the span. And what you also see is kind of like I can add some additional metadata. In this case, I'm just adding the time it is about to sleep in that thread. But basically, you can add any kind of custom data from within your application. Think of, again, that example of a retail application. A customer puts something into the cart. I can add the product ID or the product name, the product category ID as custom attributes to my spans. Why is this important? Because this will then help me to, in analysis cases, if I have some root cause analysis that is happening, maybe it is only a certain product that is having an issue in the cart, or maybe it's a category, or maybe the region where the users are coming from. So I can highly customize this and add as many custom attributes and information that I think I may need in the future as information to that span. On top of that, what also happens out of the box, we're not collecting only traces from the environment. There's also a lot of metrics that are being captured. In this case, I decided to capture metrics. It is in my control. But if I do so, I can also look at some producer-specific metrics, like the buffer available, the average I/O ratio, and so on. So I can add a lot of more detailed information that will maybe give me information about the producer side of things, and the same is also true for the consumer. So also for the consumer, I can send in and add some additional consumer metrics that maybe help me, gathering some information about why is it slow? Is it the application? Was it something happening in the application, or was it some infrastructure aspect? And also, finally, if you want to capture additional details about, the Kafka environment itself, this is then going into Kafka-specific, infrastructure metrics. What is important here is if you remember that span, that trace that we have seen earlier, and that white space in the tracing, I could then look at data like consumer lag for my Kafka environment. So how much time does a typical message spend in Kafka before a consumer reads from that topic? So a lot of detailed information about the infrastructure aspects as well from my Kafka environment. In general, OpenTelemetry has great support for many different libraries. Typically, again, I would highly suggest to go into the docs and look at what are the libraries that I'm using in my application. Does OpenTelemetry already have support for these libraries? It is the challenge for the developers of these libraries to add actually OpenTelemetry into their applications. But once they've done that, like I mentioned, OpenTelemetry is an open standard. You can then use that, and use it for any other libraries that you may be using. In this case, Kafka is really just as an example. I have the links here to the documentation. I can share this also later with you. So in summary, be mindful of what it is you want to achieve. Maybe auto instrumentation is a good starting point for you to see what is happening. It's not much effort, but as we have seen before as well, it only goes to a certain level of depth within your application. If it is enough, then fine. You didn't put much effort in, and you got fast insights into your application. But if you want to have full control over your applications, there is a way of how you manually can instrument your applications. The collector, the pipeline that we have looked at earlier, is also very useful. You can use it to add additional information, maybe delete data, obfuscate data, a lot of configuration. But it is also something that, if you're running it inside of your infrastructure as part of your application, you also need to make sure that this also scales with your application, right? Because at some point, you don't want this to be like a bottleneck in your infrastructure. And the support in OpenTelemetry is really great. Like I said, a lot of big companies are investing heavily in OpenTelemetry. AWS, Azure, Google, Microsoft, they're all investing. We are also a big contributor in OpenTelemetry. Our agents that we used for many years, they have a lot of knowledge and information on how to gather data from certain different environments. So we add also to these open source projects very heavily. And with that, there's some additional reading material. I can share the slides. You can look into more details in this. But with that, thank you very much for your attendance. Any questions?
Thank you, Harry, again. So just a reminder, you can also ask questions on Slido. Otherwise, I'm ready to run around and give you the mic to ask the questions. Do we have any? Oh, come on. It's pretty clear, right?
Okay, perfect.
Oh yeah, there is one.
Yeah.
A very basic question, but would you say any pros and cons versus Azure application insights versus OpenTelemetry? Explain a bit of the differences there.
So, like you mentioned it already, like Azure Application Insights is, a Microsoft service, right? You can also ingest then other, telemetry data into App Insights. OpenTelemetry is really like an open standard, right? It is vendor agnostic, independent of what environment you use. Maybe you want to, use, Azure App Insights or some other backend today, but maybe tomorrow you want to switch. It is just a matter of changing that configuration, the OTLP endpoint, the header information, whatever is needed to send in the data, and then you can, switch back and forth. But you implement and instrument once, and the idea is that this will be, there for the future for you to stay. But then you can decide on, what backend do I want to use to actually analyze that data? Because that is really the aspect. But I guess, to your point, I guess the aspect is it is vendor neutral. It is an open source project. A lot of contributors to that project. So I hope that answers your question.
Do you recommend to switch over?
I guess if you are at a starting point, like with new services that you're instrumenting, it's probably worth looking into, what could OpenTelemetry offer me in that case, and basically go into that direction. For existing services, it is probably worth, switching. But then again, you have to have some environment, some other environment in place that receives that data. And so,
More questions? No. Okay. Oh, there is one. 1 second, you'll get a mic.
Thanks for your presentation. Do you have any recommendations for rate limiting of tracing? For example, if we want to trace only one of n requests, can we do it?
yes. So in general, so the question is, can we, add in some sampling? Maybe we want to only add or trace 10% of the request. Is that your question, right? So yes, you have, full control in the standard configuration. It will sample the data because, there can be a lot of traces. Thinking of if you have an environment with hundreds of requests from customers, it will do some sampling by default. And then there's also some configuration that you can apply on some, it's so-called head-based sampling. So where you make the configuration of, do I want to capture that trace at the beginning of the trace? But there's also some, additional configuration on some tail-based sampling, where the decision to sample that trace, yes or no, is made at the end of the trace. Why is that important? Because at the beginning, you may not know if in the whole trace there is some error, right? Or maybe it was slow at some point. And if you make that decision to sample at the beginning, you may, not capture these interesting use cases, because that is actually where the things is that you want to optimize and maybe do some root cause analysis. If you do some tail-based sampling, you know already in that entire trace, did we see any error? Was it slow at some point? And then you can decide, I want to capture all the requests with errors, and I want to maybe capture all the requests that are slow for some reason or above a certain threshold. But yes, it is possible to sample and configure that.
I have a question.
Yeah.
So technically your talk was about tracing Kafka, right?
Yes.
And Kafka is, as you also mentioned, is more of a black box part of the system, but very reliable one.
Yes.
So where is the balance between collecting all the possible metrics and drowning them versus actually just not caring and then restarting any service that goes down?
Yeah, so I guess in the case of like Kafka, like you said, it's very reliable. In general, there's not too much you need to worry about, especially if you consume it as like a managed service. But the tracing aspect of what is happening before and after a request, this is really where it's interesting. And like I said, the header information or the trace context that is added to a message doesn't consume that much additional overhead. It will have some overhead, but having the visibility into a full trace end to end is really where the big benefit lies. And this is where I highly encourage you, also to add in some of that tracing aspect. Whether or not you want to capture the Kafka metrics that I also showed, that is something that you can decide. But I think for the tracing aspect, it is especially interesting. Yeah.
Gotcha. Thank you. So there is one. Oh, there are several ones. Cool. So, right, let's start with the top one. Any recommendations to run inside Kubernetes?
Yes, so there's also, and I think I have a link in the appendix, there's also some Kubernetes-specific operators that you can deploy, which will add some auto-instrumentation to your services if you choose to do so for maybe different name sets and so on. So yes, there is a specific aspect. You can, of course, depending upon whether you use auto-instrumentation or manual, you could add for some services and bake it into your containers and your applications. Maybe for other services, you can add in some auto-instrumentation, and this is where the operator for Kubernetes can add in the auto-instrumentation aspect for OpenTelemetry.
Thank you. I will bump up personally one of the questions.
Yeah.
We've heard that New Relic can be OLTP backend. Do you know whether Datadog accepts this tracing and metrics as well?
I'm pretty sure it does. I haven't used it, of course, but I'm pretty sure it does have capabilities, but I don't have any insights into what it is you need to configure there.
Okay, so I guess we have to just figure out. And are there any statistics about added latency using OpenTelemetry?
So adding added latency in the case of how much longer does it take to send the data into Kafka? Maybe someone can speak up who added the question. Or what part of latency are we talking about?
So I guess also if you have to, like my guess, not my question, you have to introduce specific code changes, right? You instrument your code.
Yes.
And it's a call, right? It's a resources. Do you think it can add a significant overhead in your code as well?
So for your application itself, right, if you add OpenTelemetry as part of your instrumentation, it will have some overhead. Nothing comes for free, right? In general, I would say, the overhead within the instrumentation of your application is probably in the lower percentage rate, maybe 1 to 3%. A dedicated number is not possible, depending upon how deep you want to instrument your applications. Also the aspect of, maybe how chatty is that service with the database and how much is happening inside of that application. So it's, I would say, in the lower percentage rates, the overhead. But basically, this is, the standard, aspect. You gain some invisibility, but you have to pay a little bit of overhead. If that is the question around the latency, I hope I answered it. If not,
I hope I understood the question also correctly.
Okay.
And the first one was, do you know the current status of the 70% prediction?
I have no updated information on that. The data that I showed is, I think, from 2022, and that was the prediction for 2025. I don't have an updated statistic for that. I'm sorry.
Still, thank you. So if we don't have, we do.
Thanks. One more question. We had a POC with one of your competitors using auto-instrumentation on Kubernetes, and we saw for our applications like a 10% memory increase for most pods. Do you have any recommendations in which cases you actually want to use auto-instrumentation compared to manual instrumentation? Because I guess like just writing custom spans will not result in such a high memory consumption?
It is a trade-off, right? I mean, having 10% memory increase seems like a lot. And maybe, that is an indication of maybe auto-instrumentation does too much within my application for various reasons. I could, look into configuration of the auto-instrumentation as well. Like, maybe if I'm seeing, or if I'm capturing also database requests, right? If my application, that service talks to a database, maybe that is the bottleneck. This could be switched on or off, and maybe that is a way to gather information on where this heavy overhead comes from. And if that doesn't solve it, I would look into manual instrumentation and maybe start like really high level and only go deeper in areas where I think the bottleneck lies, and then going from there. I'm having like another talk tomorrow where I'm instrumenting like a game, like an 80s jump and run game. And I played around with OpenTelemetry as well, right? And at some point I did way too much instrumentation of my code, and you couldn't even use the game anymore because it was too much happening, right? So it is a balance and a trade-off that you need to apply, but basically looking into maybe the configuration of the auto instrumentation, and if that doesn't help, going into maybe the manual instrumentation route.
Perfect. Thanks.
One more question from Slido.
Yeah.
What do you think about using OpenTelemetry for monitoring, troubleshooting Kubernetes API long requests?
That is an interesting topic, and I would consider this to be more like an infrastructure aspect. OpenTelemetry started with like the applications and services, but it will go into the infrastructure aspects as well. So you can, gather information, metrics of your, infrastructure like API requests to the Kubernetes API. We actually launched also a OpenTelemetry support for infrastructure aspects that you can use in your Kubernetes environment or your other parts of the infrastructure. So yeah, definitely, if that is seems to be like a pain for you, then definitely helpful to also look into the telemetry for your infrastructure for the Kubernetes environment.
Thank you. I think we have time for one more question if there is any. Yes?
Hello, thank you for presentation. What do you think about, is it possible to configure any alerts for long requests?
Yeah. So the short answer is yes, of course. That is then part of the, your backend, whatever you're using. I mean, we have ways on how to configure like, static thresholds. Like if a request takes longer than 2 seconds, then I want to send out an alert or send a Slack message or whatever. But basically, what I would recommend in that case is more like looking at maybe some baseline. How's your application behaving in a typical week from a historical perspective? If I see like a spike on Mondays, every Monday there's a spike in duration and it goes down, and on Saturdays it is very fast all the time. I would follow the baseline and not configure like static alerts because they typically don't tell too much. But yes, of course, possible. Yeah.
Sure, we can use percentile or something else, like to look about common behavior, and then if behavior changes, we should alert. But will it be configured on backend, or OpenTelemetry gives us such possibility?
Typically on the backend, because this is the case where you have that backend, and it could be Jaeger or some other form of alert manager maybe. But this is typically something that is outside of the OpenTelemetry pipeline in general.
Okay, thank you very much.
And this concludes this presentation. Thank you. Thank you again
Thank you for
your
attending.
talk.
Thank you.
And there was something for you as a